Oh, okie dokie, guys. Good morning. 5.2b. We have one more section after this, which puts us probably this year on Tuesday, which gives us Wednesday for review for, I believe, our test on 5.0 to 5.2, which is going to be on probably Thursday. No formative for this section. There's not an abundance of information. So basically what we're doing is we are evaluating definite integrals using geometry. And what this means, what that actually means is without a calculator. Let's try that again. Without a calculator. So, calculator. Okay. Without a calculator, okay? What I do want you to do is I do want you to check these integrals with the calculator to make sure you're doing them correctly, number one. But these problems like these, they will be on your AP test. They will be without a calculator. We will learn how to integrate these actually and evaluate these without a calculator. But right now, we're going to use geometry because you're going to have to use geometry on the AP test sometime, okay? And the whole idea behind this exercise that we got going on in 5.2b is to actually understand what a definite integral is describing, okay? And once we understand what they're describing, they're easier to find. So what we want to be able to do is we want to be able to look at this integral, number one, and this is the integral I'm talking about. We need to be able to define what the function is. What is the function that I am integrating? Well, the function I'm integrating here is just 7. It's a constant function, and I also need to be able to identify the interval that I'm integrating on, and that interval is going to be from the lower limit of integration, -1, to the upper limit of integration, which is 3. And in geometry, we can do a lot of these with geometric formulas, because that is actually, if I graphed it, that's a constant function, and the constant function is up here at 7, okay? So it's just y equals 7 is what my function is. And what I'm doing is I'm trying to find the area beneath that curve from -1 to 0, 1, 2, 3. So I'm actually boxing out this area right here. It's a very elementary problem. I am looking for the definite integral is describing the area bounded underneath that function above the x-axis, in this case above the x-axis, and it's going to translate to the area bounded between that function, the x-axis, and the vertical lines of my limit x equals -1 and x equals 3. Well, we can see that this is a rectangle. Well, pretty sure everybody knows how to find the area of a rectangle. Obviously, I'm not to scale. Area equals width times height, or width times length, length times width, however you want to do it. I have it organized as width times height because my width is going to be along my x-axis, which is going to be 4 units, right? Because that's going to be 3 minus -1 actually gives me 4 units here. In my height, because I'm not drawn to scale, well, my height is going to be 7. So all I have to do is take my width, 4, times my height of 7. So my area, my integral, is describing the area of 28. So this equals 28 is what we're after, okay? And all we're going to do is we're going to slowly progress through some different functions. Well, as I look at these, what we want to be able to do is look at this definite integral. We need to be defining what f of x is. It's f of x equals 2x, and we are looking for the area between 1 to 4. Okay, your graphs do not need to be to scale at all in any way, shape, or form. But if I graph this, I know that that's just going to be a line going through the origin with a slope of 2, so it's going to be a little steeper, and it's going to be coming up like that. And what I'm doing is I'm trying to find the area from 1, 2, 3 to 4. So 1 to 4. So as I'm looking at this, I can break this area into anything. It's describing this area right here. Well, there's quite a few different ways we can do this, okay? We can think of that blue area, we can think of it as a trapezoid. And the area for a trapezoid is 1/2 times height times the base, okay? And we can find all those in there. I don't have to look at it as a trapezoid. What I can do is I can also divide this across here. I can look at it as, if I wanted to, a rectangle plus a triangle, if I wanted to, and I could find that area. It doesn't matter how you do it. You're going to get the same exact area either way you slice it or dice it. Well, if I look at it as a trapezoid, okay, well, here is one of my bases, and here is my other base. Well, how do I find out how tall they are? Well, if I needed to find out how tall it is, I need to find out what the heck is f of 1. Well, f of 1, I should probably write it underneath here, f of 1 equals 2. So I know this is 2 units high there, and I need to know what is f of 4. Well, what is f of 4? That's 2 times 4, it's 8. So this height over here is 8. So if I used a trapezoid, I'm taking my area equals 1/2 times, my height is always my horizontal distance here. My height is going to actually be 3 units because it's from 1 to 4. So it's going to be times 3 times the sum. I messed this up. Base 1 plus base 2. Okay, because there's 2 bases in a trapezoid. I apologize. And that's going to be times, one base is 2, the other base is plus 8. So what that gives me is that gives me 1/2 times 3 times 10. Well, I look at this and I call that a 5, and I look at this area ending up to be 15. So that integral is going to be 15. If I looked at my area as a rectangle plus a triangle, well, this rectangle here, my rectangle is going to be what? It's going to be 2 times 3 plus my triangle, area of a triangle is 1/2. My base is going to be 3. Now what's my height? Well, if this from there to there is 2, and from all the way up is 8, it's got to be 6 in my triangle. Well, I can put a 6 there. This would be 6 plus, well, that's going to kick this down to a 3. 6 plus 9, 15. It really doesn't matter which way you do it. It's whichever geometric figures you see that you want to find the area of. Number 3, you're just stepping up a little bit. Well, what's my function? F of x equals negative 2x plus 6, and this is on the interval from 0 to 3. Well, what we're going to do is we're going to make a quick little graph of this guy. And of course, everybody knows how to graph that. I know I have a y-intercept of 6 up here, and I know I have a negative slope coming down, right, of 2. And if I actually put a 3 in here, well, I'm going to get 6, so my x-intercepts will be 1, 2, 3. And I'm really kind of just looking at this triangle right here is all I'm doing. Well, that's my area because I'm bounding from 0 to 3. Well, I'm pretty sure everybody knows the area of a triangle is 1/2 times the base times the height. Well, that gives me 1/2. My base, I'm going to call my base here 3 units. How tall is Mr. Triangle? Well, because he's 6 units above the x-axis, he's 6. I'm looking at the 2 to cancel the 3 to give me 9 should be the area of that. So the integral from 0 to 3 of negative 2x plus 6, when you type it in to your calculator, dx should be 9. Please check these in your calculator as you go along because it's a good task you need to be very confident with. Number 4. Number 4 spins us to a little bit different one. What's my function? Well, my function's easy to identify. It's 4 minus absolute value of x. Do you remember what the absolute value function looks like? And it's the area bounded from -3 to 3. Well, I'd kind of rather look at this as the opposite of the absolute value of x plus 4. Okay? Now you know the absolute value is a v, typically opening up, but through all my transformation rules at negative, well, what does that do? It reflects the x-axis. It's going to make it open down. So, as I'm plotting this, okay, and the absolute value is one you're going to have to be able to do geometrically because there really is not an integral of the absolute value of x. So we're going to kind of look here. Well, you can plot points. You can do whatever you want. I can think of, what is f of 0? That's my y-intercept. That's going to be 4. I'm just going to come up here, and I'm going to say, right there is 4 is where I'm going to be here. And I also want to know, hey, when am I going to be on the x-axis? Well, I know f of 4 is going to equal the opposite of the absolute value of 4 plus 4. Now, that gives me -4 plus 4. That gives me 0. So if I come in here and I put a 4 in, well, I'm on the x-axis. And also, f of, in this case, -4 is going to give me the opposite of the absolute value of -4 plus 4. Well, that's still going to give me 0. So I'm going to come out here at my -4. And because there are wings coming down at -1, I can just make my wings come down. Oop, I missed it a little bit. Let me try again. Oh, whoa, 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 whoa. Forget it. I got that one, -4. And I'm going to try this one again. Here. Okay, well, what can I do? Except I am looking for the area from -3 to 3, not -4. So it's not a triangle. So here's -3, and here's +3. Well, I'm kind of trying to find the area of this tent. It looks like a cute little tent there. Well, again, there's a couple ways to do this. I could use symmetry, because this is very symmetrical. I could divide this little bugger in half, and I could find the area of a trapezoid and take that times 2 to get the area. Or I could also kind of come through here, and I could dice it across here, and I could take a rectangle plus a triangle to get the exact same area. Whatever you want to do. I would personally prefer the trapezoid. Okay, remember trapezoid is 1/2 times the height times the quantity of base 1 plus base 2. That's a good formula you're going to memorize because you're going to have to be using the trapezoidal sum, and we're going to be looking at that pretty soon. So, well, if I do that, I need to figure out a couple things. Well, what do I need to see? I need to know how tall is this leg. Well, to find out how tall that leg is, I need to know what the heck is f of -3. Well, that's the opposite of -3 plus 4. Well, that's really a -3 plus 4. That's going to be 1. So I know this is 1 unit high here. I know this is 4 units high here. So I can actually say area of my trapezoid is going to be 1/2 times, here's 3, right? That's going to be 3 times base 1 is 1 plus base 2 is 4. That's going to give me 1/2 times 3 times 5. Well, what does that give me? That gives me 15/2. But remember, there's 2 trapezoids, so now I got to take it times 2/1. That's going to give me an area of 15. So I know this is going to give me 15. And that's exactly what your calculator is going to do if you do it that way. And the other way I could do it is I could say, well, heck, my rectangle. Well, my rectangle is 1 by, that's going to be 6 because it's 3 and 3. Plus my triangle is going to be 1/2. Well, my base there is still going to be 6 times my height. Well, now, if this is 1 unit from there to there, this has got to be 3 to here. So that's going to be 6 plus, I'm going to cancel that to a 3, 9, and I got 15 again. So it doesn't matter how you do it, you're going to get the same area, like I said before. It just depends what geometric figures you see. Well, here's a little bit different one. The easy part is being able to see what f of x actually equals, okay, in the interval on which we are talking. Except it's a closed interval because it's always going to be closed intervals on these definite integrals. Question of the day is, what is that graph? Okay, well, if you're thinking I don't know what it is, well, we can think of another way. Well, it's really y equals the square root of 9 minus x squared. And if I came back and I did this, if I squared both sides, I'd have y squared equals 9 minus x squared, don't I? And if I added my x over, I have x squared plus y squared equals 9. What is that? That's the formula for a circle with radius 3, because I can see that, and I know my center is at the origin, so this function is actually the half of a circle. And if I took my formula right here and I solved it for y, remember there's going to be a positive and a negative half of the circle. And because there's an invisible positive sign in front of that function, that means we are talking about the upper half of the circle of radius 3. So really, my center of my circle is here. I have a radius of 3, a radius of 3, and a radius of 3, and it's kind of, and really, it would kind of continue out around, but the area, that's a skanky circle, but the area we're talking about is from 0 to 3, so I'm really kind of looking at that. And if you're like, oh, I know what that is, that's a quarter of a circle. You're right, it is. Well, the area of a circle is pi r squared, so the area of a fourth or a quarter of the circle is times 1/4. Excuse me. So if I did this, I'm going to have pi times, my radius is 3, got to square it, times a fourth. Well, what is that? Well, that's going to be 9 pi over 4 is my area. So when we check this in the calculator, it's going to be 9 pi over 4. I really don't see any other shapes you could crank that into, but you got to identify this little guy as a half a circle. Well, next one is we're going to do a couple fun ones, okay, a couple special ones. And we're going to do 3 of these, and then the rest of this and a little bookwork is your homework, and we will be done. But notice on the top of the page, it says K and R are greater than 0. That means they are constants greater than 0. So anywhere you see a K or an R, they're constants, and they are positive constants, okay? So when I'm looking at my function over here, well, f of x equals k. I don't know what it is, but it's a constant, and I need my area from A to B. Oh boy, I have no numbers on here. Well, that's okay. We don't need numbers because all we need is a graph to see what we're looking at. Well, hopefully, if k is a constant and you see k as a constant, well, a constant, graph of a constant is y equals k. It's a horizontal line. And I don't know where A and B are. I can put them wherever I want, okay? So you can put them wherever. A and B, they can both be negative. One could be A could be negative, B could be positive. They both could be negative. It really doesn't matter where you put them. So I could say, here's A, here's B. Bottom line, we're looking at the area here of a rectangle now, aren't we? Well, what are my dimensions of the rectangle? Well, area equals width times height, however you want to see it. So how wide is my rectangle? Well, you know how to find how wide. You're always taking your right endpoint minus your left endpoint. Well, that thing's B minus A wide. Well, how tall is it? Well, it's going to be K units tall. So my area is going to equal B minus A times K, and if you don't like it that way, you could distribute it, and you could see BK minus AK, and either way, you would leave your answer would be fine. And even if you integrate this, you type this into your calculator, okay, you will get this out, except the CAS is going to alphabetize the letters as you pull them out, okay? These are the kinds of problems that they put on the AP test with no calculator. Lots of variables, okay? Lots of constants. Well, I can see the integral from k minus absolute value of x from negative k to k. Don't forget, k is a positive constant in this case, and I know it is because it's in the directions. They will state that in the directions. Well, f of x is going to be k minus absolute value x, or I can think of it as the opposite absolute value x plus k. It's going to be one of those inverted absolute values again, and my interval is going from negative k to k. Well, lots of people freak out on this. I have no idea how to graph this, they say. And, well, if you know it's an upside down V, okay, there's a couple important points we want to find. Well, we want to find out what is f of 0. Well, if I plug 0, that's k minus absolute value of 0. That's going to give me a y-intercept of k. So I'm going to come up here, and I'm going to put my k up there. And I also want to figure out where are my x-intercepts. Well, so f of what is going to give me plus k. What is going to, here's my k. How is this going to end up equaling 0? What am I putting in there? I don't like the way I wrote that, so I'm going to rewrite that in a different way. So I'm going to say we want our x-intercepts. So I'm going to say, what do I put in for x so that this comes out to be 0? Well, I could put a positive k in there, couldn't I? That means f of k equals 0. So if I put k in, I'm going to get 0 out. Well, what's another one I could put in there? Well, if I put the because it's absolute value, k minus absolute value of negative k still equals 0, because we have this guy over here. There's another one. Well, there we go. So, and we want to know, what is it from negative k to k? Well, negative k to k is right there. The other thing I could have done is I could have just plugged these limits into the function and said, what is k minus the absolute value of negative k? And I'm going to get 0 the same way, however you want to do it. But here is the area we're looking for. Well, what shape is that area? It's a triangle. So the area equals 1/2 base times height. Well, how big is the base here? Well, the base is k minus negative k. It's 2ky. So this is going to be 1/2 times 2k times, how tall is it? Well, how tall is it from here to here? It's k. So that 2 is going to wipe that guy out. Oh, the area is k squared. You type this into your wonderful CAS, you should be getting a k squared out. Your CAS will do that. Okay? I think I'm going to have 1 or 2 more here yet, because these are, whoa, that was 13. That was a homework problem. That was a homework problem. I'm going to do 1 more here, and I want to do number 14. Okay? This is another AP question. We're doing the integral from 0 to k of k times x dx. What is that? Well, my function is k times x. My interval is 0 to k. Well, there's a couple things I can do here. Well, hopefully you identify that that little bugger is a line, because k is a positive constant. They told us that. That's important to know. So if I graph this, okay, I can say, what is f of 0? Well, hopefully we know that's k times 0. It's 0. So 0, 0. And then I also need to know, at my other endpoint, what is f of k? Well, that's going to give me k times k. Well, that's k squared. So that means when I come out here, k units, I'm going to have a point up here that reflects the area of k squared. So here's my line. This little point there is on it. And we want the integral from 0 to k. So we're looking for the area of this triangle. Again, area of a triangle is 1/2 base times height. Okay? 1/2. What is the base? How wide is that? Oh, it's k, because k minus 0 equals k. It's k units wide. Well, how tall is it? What is this going to be? Well, what did we get when we plugged k into the function? We got k squared. So this is k squared tall. So the area is 1/2 k cubed. Plug that in to your calculator. 1/2 k cubed. And that is the area, okay? The rest of these on this worksheet, they are practice problems. There's a few in your book to do. And tomorrow we will do the final lesson, review on Wednesday for our test on Thursday. Hope you have a good rest of your day. Thanks for playing math today.